Okay, just confirm whether guys, can you hear me?
Yes, yes.
So what we were saying is like in case of the tree, basically we will have root node, and we would be able to cycle. We will not be able to cycle through that entire structure. Okay, and we cannot come back to same node again. This thing is possible in case of the graph. So basically it's like again non-linear hierarchical data structure where all the element can exist at different level, and you can cycle through that data structure, and you can traverse through entire network, and you can come back to like starting node. Okay, so that's the graph kind of data structure. Each element within that data structure will be considered as a node or vertices, and all those vertices can be connected using branches. That's something we will call as a edges. Okay, and when you go when you have to go from like vertex number 1 to vertex number 10, I'm just like putting like a random number over here. So whatever edges that you need to traverse, so basically, and like so whatever edges we need to traverse, basically that's something will constitute path between node number 1 or vertices number 1 and vertices number 10. And whenever we think about edges, so those edges can be directed or undirected. So whenever there is an arrow marking on a particular node edge, then that's something we'll call as a directed graph. If there is no such marking, then that will be considered as an undirected graph. Okay, means you can traverse it in either direction. Then there is a hashing operation. Okay, so whenever we have to do search operation on very big array, so in that situation, our search operation will be of like will take a lot of time. Okay, so if we have to like do lookup in constant time, so in that situation what we can do is we can convert that number, very big number, index number, into some hash value. Okay, so we will have some sort of function that will consume that number, and it will convert that into like some small value. Okay, or hash code. Okay, the way we have barcode in something, it is something similar to that only. Okay, and the beauty about that hash function is that hash function can take anything as input. It could be string, it could be number, or anything. So it will take that huge number as input, and it will convert that into like hash value, and it will create bucket for that thing. Okay, so it will try to put that number into certain bucket. So if there is array of number 100 means instead, if inside any array if there is 100 number, I'm just putting like any, taking any random number. So what happens, so when you apply this hash function, then you can put like these 100 values into like small buckets only. Okay, small number of buckets only. You did not have like 100 locations over there. You can do that thing in like 10 buckets only. So this conversion from this value to this new hash value or like this code is done inside this hash function, and that process is called as a hashing. So that's something will help us.
Excuse me, Mayur.
Yeah.
Yeah, you said about this bucket, right? Like 100 values will maybe
Just
stored
give
in
me a
only
moment.
10 buckets. Yes, yes.
Yeah, wait, tell me.
Yeah, so you were saying that 100 values will be stored in maybe 10 buckets. So like, do we have to provide that bucket, like that number, or it will be randomly assigned?
So thing is that like that bucket will be like created automatically. Okay, but thing is that whenever we are dealing with array of size 100, so in that situation, whenever we have to perform search operation, we need to look for like all those 100 values. Okay, we need to do comparison operation, and then only we can tell, okay, so number 47 exists at the location or index number 47. But when we pass this number through that hashing function, or sorry, that hash function, so that new code will be generated, and that number might be like put into 5 buckets only or 10 buckets only. So how it means how, so inside each of that bucket, if those buckets are like loaded equally, so in that situation, inside each of that bucket, just 10 values will be there, right? So you just need to search for 10 values. That way our speed means lookup will like lookup speed will increase. So that's the beauty of this hashing operation. And yeah, so that something makes sense when it comes to like unique values, means, and that's how these hash maps are created. Because when we think about like some dictionaries, so those dictionaries will be represented in using certain trees. Okay, so inside the trees there will be like number of nodes. If you consider that into binary search tree, we can again get like arrays and something like that. But thing is that when tree gets too bigger, when you are like hundreds of keys over there, so in that situation it will become quite hard to look for particular number. Okay. how will you check whether that particular value is equal to like what you are looking for? Okay, so let's say like you are means there is like there is a match, and like 10,000 people are like attending that match. Okay, so in that situation, like they will like come up with like some tickets, and each of the ticket will have like some number on it, right? So the guy who is at ticket counter will just check that number, but and if he start like looking for that number inside that list, then it will take like long time, right? Means he need to check for like all those 10,000 numbers. But
Yes, yes.
over here, what will happen means the number which is in between 0 to 10,000, so that will be passed through hash function. Then that will be like split into certain buckets. So guy at the counter will automatically realize, okay, so I just need to look inside this bucket, and you can do like some like more intelligent work over there. You can further create like some hash function over there, okay, some hierarchical hash functions. That way you would be able to speed up your search operation quickly. So that's how this hash operation is being performed. So basically it's just a function which takes in input, probably index value, and it convert into like some sort of code, hash value. Okay. So thing is that when we are talking about dictionary, so inside dictionary, what we are saying, it is the key value pair. Okay. So over there, inside any dictionary by default, so thing is that when we're talking about all those buckets, so in that situation, what happens? Sometimes we might have like collision over there. Okay, like two numbers might get converted into same hash value. Okay, so that's something will be considered as a collision, and that something might give like a wrong result. To avoid that collision, what we generally tend to have, we try to have unique keys at input only. That way we can ensure whatever number is being generated once we pass it through that hash function will be unique. So what we do, we try to take that dictionary, we try to take, so here we are just taking like that value only inside that hash function and getting hash value. Inside this dictionary, so dictionary is also called as a map. So inside that dictionary, we will have key value here. All the keys that we are having over there will be unique. Okay. So all the keys which are unique, if we pass them through that hashing function, we will get like unique hash keys. Okay. And in that situation, if we generate map out of it, then it would be easier for us to look for particular value easily. Okay. So let's say we have like social media network, and we are looking for particular person. So if we like just take name of that person, and if we start looking for that person inside entire database, it will take a lot of time, right? If somebody is like early in that, if we are looking for that thing in alphabetical order, and if somebody's name starts with A, then we can find his name very easily. But if somebody's name starts with M or something like that, in that situation it will take a lot of time, right? But if we convert that string into some hash function or hash value, and if we convert, so basically further what we are doing is, we are, once we get that value, we will create map out of it. Okay, means using that value we would be able to look for that thing very quickly. Once we get that number, and once that number is with like certain range, within like small limit, then we can look for that particular key very quickly, and that's something speed up our look operation, I mean search operation, and lookup become at constant time. Okay, and this hash function is something can help us in like a lot of cases whenever we have to speed up our operation. So that's all about graphs and hash. So there is like only one thing that's remaining right now, and that's about efficiency. So we discuss like when we are thinking about modularity and abstraction of our like programming languages, and when we think about primitive data types, and when we put them together inside using the combination principle, we get complex data structures and complex procedures. But thing is that even uh, if we use them, we will get like some sort of code, right? But we cannot miss, but there should be some mean to compare one code with another code. There should be some check for that, right? And that check can be done using these efficiency studies, and basically that studies are like called as like time complexity studies or space complexity studies. And to measure the performance, we use one notation called as a big O notation. Okay, so basically it's just the O followed by parentheses, and inside that parentheses there will be some algebraic function or expression. So that's something, means basically what it does, it just try to see how exactly our code is using computer resources to get particular task done. And when it comes to resources, there are again two resource types, time and space. So we need to do analysis for time complexity, and we need to do analysis for space complexity. So when it comes to time complexity, then the thing that we are generally checking for is like how much time our code takes to execute as size of input grows. So thing is that like whenever you are having like just 10 number inside that particular list, and if you try to execute that thing, in that situation you might be able to get that your code might like run quickly, okay. But once you start increasing like size of input over there, in that situation your execution will become slower and slower and slower, okay. So this is something will be considered as a time complexity studies, and this performance can be like represented using these big O notations, okay. So if you're having like some code with you, and if that code is being being executed in like constant time, like within like some certain amount of time only, then that will be like considered as a constant time case, okay. But if size of size of input grows, in that case also, if like this time to execute that code, if remains same, then that will be considered as a constant time case. If time to execute the code increases with increase in size of input, then that will you will have like different sort of like cases over there, okay. So you will have linear case over there, you will have n log n case over there, you will have like this 2 raised to n or like 2 factorial case over there, okay. So best case is like constant time case, and worst case is like 2 factorial case, sorry, this n factorial case, okay. So basically these are the things that we need to consider, okay. 2 raised to n is I believe 2 raised to n or n factorial is like worst case available over there, okay. Means as the size of input grows, time to execute that code increases, and that's something we need to keep like watch on, okay. So this is about time complexity, which tells us how efficiently we are using computer memory, not computer memory, but our resources to execute that particular thing. Because thing is that when we are thinking about time complexity, or when we are keeping watch on how much time our code is taking to our code is taking to get executed. So basically what we need to consider over here is like our code will have like certain number of sequences, and if we consider at each time instance our code is like means our computer is like executing one line of code only. So in that situation we need to see like how many number of instructions are there, and if we like measure all those number of instructions which need to be like which need to be like executed, then that's how we will get idea about time complexity, okay. So that's about time complexity. And then there is a space complexity. Space complexity is again about how exactly or how efficiently you are using space, okay. So basically if you are trying to execute particular code, and to get that particular task, if you are like if you are like copying variable from one memory location to another memory location, and if you are unnecessarily using that memory space, or like if you're, so basically just to have check on that thing, we are doing this space complexity studies as well, okay. So that whenever we write particular code, that code is that something will help us to ensure that whatever code we write will be optimized one, and we can deploy that code on like edge devices and get that thing done in real time. So that's something that's how we keep like check on this missions, okay. So there is one example that I want to tell it, and then we will probably go to demo. I know like in this session
yes, Mayur, just one question regarding that space complexity. So if I have code with 10 lines and if I have code with 100 lines, so if like, will we consider this space complexity in that, like 10 line will be more efficient than
So
100
thing is
lines?
that, so it depends on how many times you are, I mean, thing is that you might have like 100 lines of code over there, okay? But how many times
Yes.
you need to store that information, it depends, no? It depends from code to code, right? Like
Yeah.
over here I'm just like creating two variables, okay, A and N. Means I'm just occupying two memory locations.
Yes.
And just to like perform this for operation and everything. So basically this is something our arithmetic and logical unit is performing this operation, right? But these values will be again stored in these memory locations only. Sorry, these two locations only. So whether I use like 10 numbers or 100 numbers, or how, means if I do this thing like looping thing 100 times, it doesn't matter. At the end of the day, I'm just using these two memory locations. So I will have like constant memory case over here. Okay.
Okay, so it is irrespective of line of codes.
Yeah,
It is
it's
about variables and yeah.
how many variables you are creating during execution of that code, it depends on that
Okay,
space
okay.
complexity. It's not about how many lines of code you are having over there, okay. So how many lines of code you are having over there, that's something decides time complexity. Okay, so if you see this code, what here I'm doing is I'm declaring a to be 2, n to be 6. So these are like 2 lines of code. Okay, just keep count of that. Then I'm having one for loop over here, and that something will be like repeated for n times. So if I start from 0, it will be repeated for n times. So for simplicity, I will start. Let it start with 1 only. So I will means it will repeat for like n minus 1 times, and then I'm having like 2 more instruction over here. Okay, but since this code is gonna repeat for n times, and I'm having 2 instruction over here, means I need to perform this 2 instruction n times, right? So it will be 2 times n, and this 2 instruction before. So 2 times n plus 2. So these many instruction I need to perform, and then there is a one more instruction, that is a print day. So 2 times of n plus 3. So that's gonna be means this many instruction I need to perform over there, okay, in order to execute that code. And 3 times of n plus 3 will like decide our time complexity or the time our code takes to get executed. So let's say if our operating speed of our computer is like some, we generally used to have like that speed in gigahertz, right? Is our operation computer can perform like 2 trillion operation per second or something like that, right? Means in advanced computers.
Yes.
2 tops or something like that. So means in that situation our computer can perform these many operation per second. So over here I'm just having I just need to perform this 10 operation, right? Means if I consider n to be like 10, then in that operation, in this situation, I just need to perform 23 operations, and that's how I would be able to calculate time that my code need to get executed, right? So that's the time complexity. If I change size of this input from like 10 to 100 or 1000, then like number of times I need to look through these 2 instruction will change, and that's how like time to execute that entire code will also change, right? So how exactly this increase is happening, that's something will be checked during this time complexity studies. And how many times I'm saving this information, means how many variables I'm generating during perform executing this code will be like will be checked when during the space complexity analysis. Okay, since we are like size, even here our size of input is growing, still the memory space that we are using is same. Okay, so that's the reason that will be considered as a constant space. But let's say if we are like doing some other stuff over here, in that situation we might need to do some copying or something like that. Okay, so in that situation this memory complexity will like differ. But in most of the cases people generally try to give like, because thing is that there will always be trade-off between time complexity and space complexity. Okay, so we need to decide like what we want to go for. Means there will be like upper constraint on space, but time is something we really need to like, we really want our code to get executed as quickly as possible. Okay, so we means often try to give more preference to time as long as we are below that upper limit. Okay, and once we start getting beyond that thing, we try to like keeping some constraint on that space as well. Okay, but that's about like, that's how this time complexity is calculated. Like we just need to like calculate how many instruction are we need to execute inside this code as size of input grows, and that's how we will like, we will generate this algebraic expression. That's something we need to put inside this big O inside this parenthesis, and that's how we get idea about our like time complexity. Okay, but here we just need to do some approximation. So plus 3 is nothing, it's really small value, and 2n is again small value. So we need to convert this thing into O of n. So O of n will be considered as a time complexity of our code, and for space complexity it will be considered as a O of 1. So O of 1 means constant time, because this two thing means 2 variables is something not changing, right? So that's the reason it will be considered like constant time case for space complexity. So that's how we calculate time complexity and space complexity, and that's something decide, or that's something help us to distinguish or differentiate one code from another on the ground of efficiency. How exactly that particular code is being executed, or which code is better than another.